In this video, we continue to learn how to name binary ionic compounds. In the prior video, we have learned how to name binary ionic compounds formed between main group cations and anions, with a few exceptions. In this particular video, we continue with this description by learning how to name binary ionic compounds between transition metal atoms, which will form cations, and then those anions. Okay, the exceptions to this will be silver, zinc, okay, which are transition metals, but we actually, for these elements, we use the naming convention that we had for main group cations. Now, the main reason that we actually make a distinction between main group and then transition metals is that transition metals tend to form more than one type of ion, right? So, for example, while for the alkali metals, they will always be +1 ions. Okay, when you take, for example, iron, which is right here, iron can form +2 or +3 cations, right? And in the naming, we actually have to specify which one of those we're talking about. Okay, the reason that silver and zinc are exceptions are because those transition metals only form one type of ion, right? So there's only one charge that they can have, and then we don't have to specify what that charge is because it's always the same. For the rest, again, they can form various types of ions, cations, and then we have to specify the charge. All right, so the way to name these compounds then is actually very similar to what we have for main group cations. The only difference is that we specify the charge of the cation with parentheses and Roman numerals. All right, so let's then think about how we would name a compound between iron and oxygen that is like this. Okay. Right, so we know that oxygen is always going to be -2 when it forms anions. Okay, that will be an oxide, and that means that, well, since because this charge, this compound has 0 charge, is neutral, then the charge of the iron cation has to be +2. All right, so then the way to name this compound will be iron parentheses Roman numerals 2 oxide. Okay, let me actually write that. This compound is iron 2 oxide. Okay, and again, the only distinction with what we have seen with main group elements is that we would not specify the charge between parentheses with Roman numerals for that other class that we have already seen. All right, so other compounds, for example, if I were to ask you, well, please write the formula for the compound iron 3 oxide. Okay, so if we actually have iron 3 oxide, then we know that the two elements that are forming that oxide will be iron and oxygen. We know that the charge of oxygen will be -2, and the charge of iron will be 3. Okay, so the only way to make this balance is if we actually write this 2 and 3. Okay, these are the smaller whole numbers that actually give you a charge neutral compound in which the charge of iron is +3 and the charge of oxygen is -2. Okay, notice that the charge corresponding to the iron atoms will be 2 multiplied by +3 will be +6, and the charge of the charge of the oxygens will be 3 times -2 will be -6. Okay, so that gives you a charge neutral species. Now, the way to name this is again would be iron, but then the parentheses will be 3. Okay, so iron 3 oxide. Okay, so again, we're learning how to name compounds, how to specify the charge, and so forth. Okay, the rest can be applied to this naming convention can be applied to the rest of the compounds that you can form. Let's write a couple more, just for the sake of completeness. Okay, let's examine here the name of this compound. Okay, there will be a binary ionic compound formed between lead and chlorine. Okay, so the charge of chlorine is always -1. This means that the charge of lead in this compound is going to be +2. So the way to name that compound would be lead parentheses 2 close parentheses chloride. Okay, and then this other compound, Cl4. Okay, then the name of this compound will be in this case lead parentheses 4 close parentheses chloride. Okay, so again, this is the second class of binary ionic compounds that we name. And again, the important thing about these compounds is that in the naming we have to specify the charge. And we need to do that for transition metals, except for silver and zinc, because those transition metals tend to form more than, or can form more than one type of cation.